Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are starting the last unit of the grade 12 physics, which is the unit D, atomic physics. So this is the very much like a theory heavy unit. We focus on the more theory part in this in the first half, and then we do some equations too, but we are more focused on again with the theory. So we do the all three units: momentum and impulse, forces and fields, electromagnetic radiations. We all three chapters are collab in this unit now, but we are using the same formulas we used in that three units, but we do some I think we do some one or two new formulas, but the rest of things are same. This chapter is very easy unit, easiest units of grade 12 physics, and we just have to know some theory, some equations, and the back three units. So let's start this unit, and we complete that unit as soon as possible. This is like a short unit too. So let's start with the first topic. We're doing the now today we are doing the discovery of the electron, which is the Thomas model of the atom. So we are in the now in the few lessons we do the few lessons when we do in this unit, we are doing the discoveries. We do the discovery of electron, nucleus, atom, and some shells and levels. So these are the models which inventors do, like the Thomas with the Rutherford, Bohr model, quantum model. We do these things. So let's start with that and learn more about the electron. You all know what is electron, but how this discovered, we don't know. So let's start. So at the start of the 19th century, English chemist John Dalton proposed this atomic theory. The theory he proposed in 1803 was a good start, though it had a few flaws that were corrected over the course of time. The four main points of Dalton's theory were: the John Dalton that opposed the four atomic theories, they opposes atomic theory and they opposes the four main points of that Dalton's theory. So what are those points? So first point is no matter is made of atoms which are indivisible and indestructible. So this is the incorrect one. So this is the theory that first two things, which is all atoms of a given element are identical in mass and properties. This is also incorrect. These first 2 points we discuss in this whole lesson. By the end of this lesson, we will consider these two are also correct. So the last two ones are the compounds are formed by the combination of two or more different kinds of atoms, which is like orally proof. So this is correct, and the chemical reaction is rearrangement of the atoms, which is incorrect. So as we progress through this unit of the atomic physics, we will see why the first two statements are not correct. So why they are not correct? If they are correct, so who opposes that this is correct? So that's all our point to do in this unit. Before starting with the actual discovery of the electron, the discovery of electron can be done with the different discoveries. The different discoveries involve that first discovery. So that experiment called the cathode ray experiments. We all are familiar with the cathode. Cathode is the thing that we have anode and we have cathode. When we do some electrical thing, when we do some voltage thing, so that two things are involved in that. So the first thing we have, throughout the 19th century, scientists quickly discovered that connecting a high voltage source across the opposite ends of the vacuum tubes caused the mysterious rays to follow them a negative electrode, which is a cathode, to a positive electrode, which is an anode. So we have that electrical diagram over there. This is a tube, vacuum tube we have. So we have a high voltage over there, which have a negative and positive charge, and we have a cathode and anode. So when they connect these all things, they will see that the mysterious rays, we have some mysterious rate following through over there from the negative electrode, which is our cathode. So negative electrode is a cathode and the positive one is the anode. So the mysterious rays are going from the negative electrode to the positive electrode, as they mentioned over there. These mysterious rays are called the cathode rays. So why they name them the cathode rays? Because the rays are originate from the cathode rays and go to the anode. When passes the rays cut in the anode, the glass tube begin to glow. When they flow, the rays are stuck to the anode. They stuck to that anode, and from here the tube will be glow up. So how this whole thing happened, this can be further be explained by the Thomas. So the real groundbreaking work was done by the British physicist, the Sir George John, which is called the J.J. Thomson. and he did intensive work around the cathode rays. After that, they will do some work in that further with the cathode rays. For this experiment, this can't tell us about anything about the electron discovery. So they're more doing with that. So what's the Thomas experiment they do? They devise the two experiment. They again revise the all the experiments with the cathode rays done by the scientist. So what are those? They separating the negative charges from the cathode rays. Firstly, they separate the negative charges from cathode rays. So eventually, Thomas realized that cathode rays themselves were the negatively charged particles. So they mentioned firstly that the cathode rays are the negatively charged particles. So this question is commonly given in your like MCQs turn, that what charge have the cathode rays have. So they have a negatively charged, and hence this is not possible. But this is not possible through according to the Thomas one. So they determine whether the negatively charged cathode would deflect under the influence of the electric field or not. Now they do. So they made some electrical field. In the electrical field, they will put the negatively charged cathode rays in it, and they see that if they would deflect the influence of this in the electric field or not. They determine that. So previous experiments failed to demonstrate this effect. The Thomas hypothesis the cathode rays likely ionize the air molecules and they shield the cathode rays from the effects of the electric field. So from the effects of the electric field, to like minimize that, to like they shield the cathode rays. So they shield the cathode rays and they likely they ionize the air molecules which from the effects of the electric field. So that they do when the Thomas hypothesis that. So eventually, after doing these all things, Thomas can conclude this thing that Thomas experiment has shown that the instance of the fundamental particle with the negative charge. So there's a very intense thing. There's a very large part of negative particles here. This will become the discovery of the electron. They will name this as the electron. So from here, the electron can be in the like we can say electron can be in the use in that way. Electron can be discovered from here, but there's still some things can be revised again and again. So that things then Thomas can do again after that. What they do first? They will calculate some charge to mass ratio. What is that ratio? So at the time of the Thomas experiments, we did not have the method of imaging the mass of an electron. They discovered the electron, but how can we discover the mass of the electron? Because that electron has some mass. If they have a large of the negatively charged particles, that show that this will have some mass of that. So we have nothing to measure the mass of the electron, know the charge that it carried. So we don't know how much charge they have. However, Thomas realized that we could calculate another value of interest, which they call the charge to mass ratio. The charge to mass ratio is going to be the Q upon M, because Q is the charge and M is the mass of the electron, by using the knowledge of the electric field and the magnetic field. As I told you, all the three units of the last tutorial come in that unit, which is that the electrical fields and the magnetic fields we done in the Fujita fields. How they use these knowledge to calculate the charge to mass ratio. How they do that? So the Thomas use the modified cathode ray tube, which is a CRT, to carry out the experiment. They do like something like that type of structure they done, but do not like know about this structure because this structure is not coming in your exams. But you have to know that how they use the knowledge of electric fields and magnetic fields to calculate the charge to mass ratio. So for this, we have to consider some the equations in that now. So they firstly, in the first step, the Thomas turn on both the electric and the magnetic fields and adjust their magnitude until the cathode rays pass through a CRT undeflected. They on the electric and magnetic field and they pass that fields to the CRT until they did undeflected. Previously, he saw that particle paths through crossed fields undeflected mean that the magnitudes of the electric force and the magnetic force are equal but oppositely directed. So what they mentioned that when the cross fields are undeflected mean that the magnitude of the electric force and the magnetic force should be equal but the oppositely directed. So over there they do that. You can do this already in the Fujita fields, that we have that electrical field over there, we have electric force over there, and the electron moves towards this positive and the negative plates, and they generate some magnetic field and they have some electric field in it, and then they're involving the forces, magnetic force and the electric force. So from here they pose that they both are equal. So the electric force is equal to the magnetic force. They firstly pose that. So So you know that electric force is equal to the Q times electric field is equal to this, that magnetic force is equal to the Q times V, which is the velocity, times the magnetic field. When you cut the Q's, you get the V is equal to electric field divided by the magnetic field. You will get this formula. You already done this formula in the forces and fields. So from that first step, when they turn on the electric field, magnetic field, you get this equation. After, in second step, what they do? In second step, the Thomas turn off the electric field. Now they turn off the electric field such that only the magnetic field was present. Now only the magnetic field can be involved in the second step. This means that the electron will undergo circular motion with the centripetal force provided by the magnetic force. So if the magnetic force is only on, the magnetic force eventually doing this some force called the circular motion, which is called the centripetal force. You already done this too in the forces and fields. When the magnetic field is involved, the present the electron undergo a circular motion like that. And we have some centripetal force and we have some magnetic force in this. So now we have a centripetal force and we have a magnetic force. That circular motion, that centripetal force, that equation is not even a formula sheet. You have to memorize from the forces and fields unit. Like this is mv square upon r, which is equal to again qv, the magnetic field of this fm. And from here, when you cut this v from here, you will adjust that thing to the charge to mass thing, which is that is q upon m is equal to v upon magnetic field times r. You will get this type of thing. Eventually, when you're combining the both things, like over there, that v is equal to the E upon B, which is electric field over magnetic field. So you get the v value you done something and you get this, and the magnetic field square times r. So that qm is equal to this 2 and this 2 when you consider both the things. So from the first step and second step, they propose some equation of that, and we have to use this equation to calculate the charge to mass ratio. You get that type of questions in your examination diploma. We use the example at the end of this lesson. So firstly, something you have to know from this, again from Thomas. After they pose that charge to mass ratio, they will do some they tell some experimental theory of that. So the Thomson had found that an experimental way to determine charge to mass ratio of an electron by using the magnetic of the electric field and the magnetic field, use as well as the radius of curvature, which is r, of the electron when it underwent the circular motion. So that all the things they do and they get the charge to mass ratio, which is their thing they want. So when they calculate the charge to mass ratio and they calculate the electron charge to mass ratio, so get the 1.76 into 10 raised to 11 coulombs per kg. So that's the charge to mass ratio of this, and you have to know this. I think we sometimes use this, but you have to know this. Sometimes they give you the MCQ questions about that. Measured by the QM with a series of cathode rays for different metals, found the value of the reasonably consistent, leading to the reproducibility of the experiment. So this will, when they use this, when they do with another metals, different metals, they will get some consistent things, and that will the experiment can be done by the Thomson's experiment. The conclusion is that all the cathode rays consist of identical particles with the same negative charge. That all the cathode rays of the identical particles are made up of the same negative charge, and the atoms are not the smallest unit of the matter. From here, they invalidate the Dalton's model of the atom, which we discussed in the first 4 points, that the atoms are not the smallest units of matter, but composed of the even smaller units. They invalidate the Dalton's model of the atom as the conclusion of the cathode experiment. So the Thomson model of the atom can propose a new formula with something called the pudding. So besides being the discoverer of the electron, J. Thomson also poses own. So this the cathode is not their own experiment, but they also do with this but they also pose some their own discovery of the electron, that with the Eisenberg model, which is called the plum pudding model. Like this, you see. From that plum pudding model, they report that electrons are there. They discover the electrons from here. So what actually do the time of Thomas discovery of the electron, it was known the atoms were electrically neutral. Even matter if electrons exist and it were part of the electron, there had to be part of the atom that was positively charged in order to balance off this negative charge from the electron. So the negative charge of electrons should be balanced out with some positively charged electron because there's a large number of negatively charged particles in any atom. So for to balance this, they propose is that there should be some positively charged in order to balance that. So Thomas theorized that electrons of an atom were abundant in the massless blow of the positive charge, similar to the way essence or the electrons are abundant in the dough positive charge as a SN1. So they use the pudding model, like how the essence are put in the pudding. So that's how the electrons are in the case of this electron thing, like the atom. So, but this is like a very big drawback of this experiment. This thing can be further explained by the Rutherford's model. So Thomson's model of the atom was the first proposed that matter is made up of the discrete positive and negative charge. So they propose that the atom is made up of the many discrete of the positive and negative charges. But this is not true in that case. Somewhat is true, but they have some drawbacks, which can further be de-revised by the Rutherford. So in the next lesson, we're doing the Rutherford model, which continuity of the electrons discovery. In that, we discover the nucleus. So nucleus is discovered by the Rutherford, and we do that model in the next lesson. But for now, this is the discovery of the electron. We have to say some example for that for charge to mass ratio. You can commonly get the questions from here. So the question says the correct cube with the electric field strength of this and the magnetic field strength of this between the places set up. These settings result in electron traveling straight through that is undeflected when they are both turned on. After shutting down the electric field, the path of electron is measured to have a radius of 0.325 meters. Determine the charge to mass ratio according to experimental data and variable. So this is all the experiment the Thomas do. So we have to do like this experiment. So they said that there is an undeflected thing, which means your force is equal to the net force equal to 0. So firstly, it is for only the magnetic field. So for only the magnetic field, we done for. So for magnetic field, you have a centripetal force is equal to the magnetic force. We make a formula from here. So mv square upon r is equal to qv magnetic field. From here, mv upon r is equal to the qb this. You have to find the charge to mass ratio. You can isolate the q upon m and you get this. But you don't have v from here. You have magnetic field, this is over there, and you have r2, which is over there, which is the radius of curvature, but you don't have v. You found v from the first step, which Thomas does, which is when we involve the electric field and the magnetic field both. When we have this both. So from here, magnetic force is equal to the electric force, where our net force goes to equal to 0 because it's undeflected. So it's q times v times magnetic field is equal to the q times electric field. Q cancel out, you get v is equal to the electric field upon the magnetic field. So electric field given to you, which is 1.86 into 10 raised to power 4 Newton per coulombs. Magnetic field given to you, which is 5.80 into 10 raised to power minus 4 Tesla. When you calculate this, you get a v of about 3.206 into 10 raised to power 7 meter per second. So this is your velocity, and now this velocity can be like put over there. So you put net velocity over there, which is 3.206 into 10 raised to power 7 meter per second divided by the magnetic field of 5.80 into 10 raised to power minus 4 Tesla, and the radius of r is equal to 0.325 meters. When you calculate this, you get about q upon m of 1.70 10 raised to power 11 coulombs per kg. This is like the experimental thing which the Thomas did. So this is the same example. So that's how it solved this whole thing, and that the charge to mass ratio according to spirometer data. So that's all you have to find from QR pen. So sometimes we had some different questions related to only the plates, like we do in a force and fields. That's involve the charge to mass ratio questions. We discuss questions when we do the practice question of this particular part. So or in the diploma questions too. So that's all for the discovery of the electron, which is basically done by Thomson model of atom. But there are some drawbacks which can be done done by the Rutherford model, and Rutherford model can be discovered the nucleus. We discuss that topic in the next lesson. For now, this is all for this lesson. So let me see where EduVibe learn smart not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, stay with EduVibe.